So, welcome. How many of you are actually here for Safecracking? Phone on. So we're going to talk about more or less combination locks, because that's what most stuff in the US actually uses. And I realize our thing's small. We had to put the projector in the main room. Slightly more important. So how many of you used this type of lock ever? How many of you basically went to high school? I would assume most of you. Right? So these locks, as you probably know already, are really, really bad. And it's not because they're master lock or because they cost $3, but just the way they're made and the design of the internals is pretty bad. And basically, you may as well hang a do not disturb sign on whatever you're trying to protect with this. And so you may say, well, I'm just protecting my gym shorts or whatever. But you know, the more you start working with locks, the more you notice locks are everywhere. And even on important stuff, people use stuff like this, or the equivalent pin version of the master lock. So here's a very visual example. There's your locker. How about that? Slightly better? So the main way that these are defeated, foregoing manipulation for the time being, is we make what's called a padlock shim. And basically what a shim is the way that this bolt is held in place is just by a little spring-loaded piece. And when you dial in your correct combo, and then you pull on the shackle, what you're doing is that piece is free to move back, so you pull your shackle out. But there's many other ways that you can open the shackle without working with the dial. So this one's really beat up because it goes with me to basically every conference ever. So what's really funny is that it's so beat up that you can actually just push the piece out of the way that holds the shackle and retract it. So again, this is a beat up old lock, but the same concept applies to a brand new one. Now it may be harder to push directly with the pick, but there's all sorts of other fun stuff we can do. So again, we said the first thing is shims. So what a shim is we want to be able to displace the shackle from the thing that retains the shackle. That's essentially what we're doing with the dial. We're just allowing these pieces to disconnect, and then the shackle can open. And you can make shims out of Coke cans. Let me see if I have a nice Take it away, Scorch.
Take it away? All right. I'm taking it away. Not sure where I'm taking it to, but as you mentioned, the reasons why these work is because it's essentially just a spring-loaded mechanism. It's just a little nose, folds in, because if it's not a spring-loaded mechanism, well then, in the case of those master locks, the only way that it would be able to open is if you dial the combination again, and then would be able to close it. But of course they made it spring-loaded, so there you go. But you wanted to use your scissors. Did you want me to go into other combo locks, or you're covering that?
I'll do.
All right.
We got time.
Didn't know where you wanted me to take it away too, so.
Okay, so what you want to get is you want to start with a little rectangle of a Coke can. It could be a little bigger than this. This is one of the smaller ones.
Yeah. Usually I like to make it just about like 1 inch by 2 inches. It's a very easy way of remembering things.
And so what you want to do is you have your piece, you take a Sharpie, and eventually you don't need to do this, but it's good to get in the habit of it so that you're doing it right. You take your Sharpie, mark it like that. So you divide it that way, and divide it all the other ways.
So you're essentially just dividing it into 16 equal pieces.
Yep. Like this, okay. And then you're going to make some marks as a guide for where you want to cut. So I added my marks, it's kind of hard to see. And then you're going to connect them with a nice smooth line. You don't want to make very jagged or flat edges, because when you use this tool you don't want it to tear.
And any sort of incongruity is in that nice curved shape. We'll basically want to encourage it to tear even more.
So here's all our dots connected, nice curved lines. Okay.
That's from a Coke can?
This is from a Coke can. And actually beer cans work a little bit better because they're slightly thicker depending on the beer.
I think this actually was an orange juice can,
Yeah.
but
aluminum. And then that bottom part is what we're going to cut out. and here. This one's super flat, so it's not 100% good example, but you guys can pass it around. It's basic idea.
Now, is it preferable to have soft metal like aluminum, or would a steel shim work, or would it screw things up?
It works, but it's harder to make by hand, obviously.
The problem is I mean, that's what the mass production ones are.
Yeah.
Is they're basically a variety of steel, but of course they're using very big machines in order to
Sure, yeah.
be able to curve it and do it however you need. The nice thing about these, with the aluminum especially, is you can just basically cut it like this and get all ready, and it's flat. And you can put it in your wallet, you can take it anywhere, and then if the need ever arises, of course in a perfectly legal and ethical manner, but if the need arises, you can then, fold it just as he's about to show you, and then turn it. There you go.
Cut out my bottom parts. So I have this kind of weird curvy M. And then I'm going to fold it.
So the first step is you want to fold it down to that center line.
Like that. And you use the lines you drew as a guide. And then you're going to fold the legs up and around so you don't cut yourself.
And this also helps to reinforce the handle.
As you will see how it
Now
works.
we're like this. We roll those edges around. Make sure there's no sharp parts that you can poke yourself. And then,
Curve it around this.
yeah, and then what you can do is if you have a pen, you just want to make this round so that it fits the curvature of the shackle. Now you can do it with the shackle, you do it with a pen, do it with any number of things. It just needs to be nice and round and smooth. So here is our finished shim. Okay. Now, if you look at it now, it'll make more sense why the edges are all curved. Because we have really flat edges, it's going to be easier for this middle piece to tear. And if I'm not an asshole, we'll get this on the first try. It's been known to not work out that way, though. So what you're going to do is the shackle retainers on this side. Obviously, you need to know that beforehand. Sometimes you need to shim both sides because there might be a double retainer.
So that's only on other padlocks, not just these.
These the ones have a single. So put it down here. And then you're going to pinch the arms and turn it around so that it gets in between the shackle and the detainer. And then you should be able to figure it out. Okay, did not get it.
You want me to do it?
Oh, it ripped the shim. So what happens if you do it wrong is it'll just tear the shim, and then obviously the lack of material will not let you shim it. But it happens. You can just make another one. Yeah. You want to make one?
I'll make one more. You keep going.
So that happens, and often you'll find you have padlocks that have a bunch of little shim aluminum stuck in the bottom.
Where's the pictures? There it is.
Yeah. Okay, so that's the basic idea. He's going to work on another one, so we can keep going. One interesting thing is that it's also possible to decode these by feel. Now, with this method, you don't get the combination directly. When the shackle's open, you could actually figure out the combination by poking and prodding inside. But there's also a way to do it just by feel, without making any tools, without worrying about tearing your shims. Obviously, it takes a little bit more time because you're sitting there feeling it out, but it's just as effective. And when you get good at it, you can do it pretty quickly. One fun thing is that these are so poorly made that they actually make it easier for you than you might think. So there's 40 numbers on the combination, 0 to 39. So, we have 3 numbers in our combination, so how many combinations should that be? A lot, right? A lot, theoretically a lot. But the way it works is that when you dial in your combo, let's say your combo is 10, 20, 30. You can probably dial 9, 20, 30, or 11, 20, 30, and variations of that for each number in between. Because the way this works is that it has a certain tolerance so that you don't have to dial exactly correctly on the line every time to make it a little bit easier and more user-friendly. So we could use this to reduce the key space, essentially. And for these locks, they have a really big tolerance. So I think it's something crazy like plus or minus 2, the actual number you want to work with. So in actuality, instead of 40 numbers, we have basically 10. Slightly, given to some variance, but about 10 numbers per dial. What we can also do is exploit a problem in this type of lock to let us just figure out one of the numbers right away. So if we know one of the numbers in the combination and the other two wheels only have 10 possibilities each, we only have 100 combinations to try to brute force this really quickly. And there's some more advanced mathematical stuff that you could do to figure out even faster. But the basic idea is that you're going to pull on the shackle. And what pulling on the shackle does is it directly tries to push the retainer into the gates inside of this. And we'll talk more about how these work internally when we get to safe locks. But essentially there's just little wheels with gates, and when you dial it in, you put the gates in the right position. So when we pull the shackle, we're pushing against those gates. And when we try and turn the dial, we'll find we're stuck. So I can't turn the dial more than from about 26 to 27. And so, okay, we know that. We can go from 26 to 27. Let go, move a little bit, pull again. The next part we get stuck in is 29 and a half to 30 and a half. So you're going to do this all around the dial, and one of these little gaps is going to be different. And so what these are false gates. So that if you just tried to pull and there were no gates, you would just be able to click into all the correct positions because you'd be pushing the piece directly into the wheels. So with these false gates, they try and make it harder to manipulate, but it actually has the effect of letting us just figure out the last number in the combination right away. So again, I'm not going to sit here and do it all the way, but you're going to pull, you're going to check, you're going to write all this down, and then of these little gaps, one of them will be an outlier. It'll be bigger, it'll be smaller. It varies depending on brand and model. But in the master locks, they're typically a slightly bigger gate, and that's because they want it to be easier for you to find when you dial in your combo. And after you have that, let's say our number is 6, so we found 6. All of the other two numbers will be offsets of 4 from your number 6 because of the way they mass produce these. So what you know the last number is 6, okay? You're going to dial 006, 046, and you're just going to run through the 100 combinations really quickly. And ideally, you should find it within 50. And dialing in 50 combinations is pretty quick once you know what you're doing. And then you would have the combination, you'd be able to come back anytime and open it. So it takes patience and practice. The first time you do it will be the hardest, but if you do it once, every subsequent time will be considerably easier. So there's a lot of these on the tables if you guys want to practice. Just start by pulling on the shackle, finding all these little gates, and figuring out which one is different, and therefore you have your last number. Then you can try the other 100 combinations, and you'll open it really quick.
And if you don't care about the combination, we can still do the shimming, which basically just make the shim, put it on that side, and the important part is to maintain that downward pressure as we rotate this around inside the lock. And I have weak grip, so I use little pliers.
Pliers are definitely more helpful because you don't have that stutter when you try and move it with your hands.
And so now it should be fully shimmed, and all I need to do is pull up, and it's open.
And you guys can all try this. You try it on this lock, you can try it on a nicer lock.
Yeah,
But
the ones I have out there are a little bit less beat up. But
yeah. It's very easy. Just do what I did with the Coke can. I'm sure y'all can figure out how to manufacture it. Yeah.
Yep.
And if you ask Dan nicely, he might.
And I think I'm out
like
of
borrow
aluminum at this
scissors.
point, but if anyone else has been drinking a Coke can and wants to just wash the stickiness away and give it to me,
Is that his?
yeah.
Right one.
Well, this one has been.
I don't.
He's one of the guys who didn't go to.
Okay. Everybody want to play with this one?
Yeah.
Okay. So the other fun stuff are called sesame locks, or just, they're another form of combination padlocks, but for some reason they're called sesames. I never quite understood why.
It's because probably the most popular brand in the U.S. lock was Sesame. So
Previously.
yeah, previously.
Okay.
Open Sesame.
Yes. Okay, so these are very similar, just 3 wheels or 4 wheels, and each of them has a number. Unlike, obviously, the dial one, you have individual dials for individual wheels. And the way these work is that when you pull the shackle, these discs are physically blocking you if they're not in the right position. So it's very similar to the other lock, but just a different way of doing it. I would say that these are considerably easier to manipulate just based on their design, because you don't need to worry about dialing and making sure you're dialing in the correct sequence, because that's a big problem for for people who use safe locks and those combo locks, it's like, oh, I forgot how to dial the combo. But with this, obviously, you just put in, 1, 2, 3, or whatever your combo is. So the way this works is pretty much the same, but it's a little bit easier. You put pressure on the shackle, pull up. Some you have to push down, but I think for all the ones we own,
Yeah.
you pull up. You pull up, and then you're going to test each wheel. So if you don't pull, you can move each wheel very freely, right? When you pull, the shackle is going to be pushing against one or more of the wheels at right now. So when you try and turn it, you'll see this one moves just as freely. This one is a little bit harder, and this one's really hard. So what that is the shackle binding up against each of these wheels in a different way. And just like when we work with a pin tumbler lock, each of these wheels will bind in sequence because of the way that the shackle's pushing up against it. It can't really be manufactured to push against all of them equally at the same time. So what you could do is work on each wheel individually. So I'm going to pull. I found that the first one gives the most resistance, and I'm going to turn it until I feel it click into place.
So while he's doing that, it's also important to note that whenever you look at these, just imagine a J shape, because that's essentially what the shackle is it starts way up here, and then it goes around just like that. And so when you have on this side of the shackle is, of course, a tube of metal, which is that part of the shackle, with little flags or protrusions on it. And those flags or protrusions, of course, are being blocked by these gates because it's just a solid piece of metal. But when these are aimed at the correct number, there, of course, is a hole in that gate. So you imagine it, you have this little gate right here, and this flag is trying to move through it. It can't, right? So until it rotates, there's the gate is exposed, and the flag and protrusion will go right through. And there you go.
It's really easy. Like, I know I didn't say anything because all I'm doing is just pulling and turning until I feel things click into place. But you can all do this. And so we have a number of these that you guys can pass around. Your business. And so obviously 4 wheels takes a little bit more effort than 3 wheels, but they're essentially the same thing. You just have an extra wheel to work with. So just pull on the shackle, find which wheel has the most resistance, and then turn it until you feel it click. Go to the see if the next wheel is the one that you're supposed to turn, and so on. The next thing we're going to talk about is safes. And so safe locks are essentially just big boy versions of the little mini master lock combo locks. Very similar principle. And we have a bunch of other master lock padlocks that look very different, and most of them will work on the same principle. So this one, you have a dial on the bottom and a big button. So instead of pulling on the shackle or pushing the shackle, you push the button to directly interface with the wheel pack. And you'll feel, you can even hear I'm getting stuck in all those gates, like click around it. But we have a couple of these, you could play with it. For this one, it's actually easier to just take a dial caliper and just squeeze it while you're manipulating it. And then you could feel as the button goes lower and lower until it opens, as you're testing all these numbers. It's kind of fun. This one in particular is called the Master Lock Axis or Master Lock 1, different names in different countries. And it has this little joystick thing. And speed dial, I believe, is the American term. And so it's a little joystick, and what you do is you dial, up, down, left, right, whatever. It's actually, in theory, infinite number of permutations, but at a certain point you reset everything to a given point. So I think the max possible combo is like 23 movements before it becomes non-unique. So you could put whatever you want. I don't know, what is the factory combo, like down, down, up, or something like that?
It varies. They randomize it. So
Super.
yeah, usually it's 4. Like down, up, down, down, or something.
And we
like that.
have one here that's taken apart that you can see. It's
Currently in
very
pieces.
complex inside. It's kind of hard to explain. Essentially, every time you move this, it's moving like 5 different things.
So what happens is that front little button right here, all that does is move this plate, and you probably can't see it from there. But this plate has many, many little protrusions there. Those protrusions go around in these specially shaped discs that DJ will push around as well. And so if you just get like a straight piece of metal or a pick, you can kind of see if you move up on this, it'll move up a certain amount and then go down and move it a certain amount. You move it up, it'll go into that push and go down a little bit. same on the side. So these are designed that it has a straight piece of metal going any side of them. It will move them a pre-described either a full amount or a half amount. So you can pass that around if you want.
Sure. Just make sure you get to back.
Yep. But it's actually a really ingenious little design. If you want to know more about it,
It's very steampunky, just a big shitload of gears that all turn together.
If you want to know more about it, you can go to tool.nl, and there actually is a little visualization tool. It's just in Flash, and you can kind of play with it. And
Yeah.
You can see how the internals all work. So
So like I said, we're going to talk about safes. Safes are very similar, but also very different. The same basic idea of you have a number of wheels. I'll pass this one around. This is a cutaway I'm passing around. The idea is you have a number of wheels, and they're controlled by the dial. When you position them correctly, the arm up on top will fall into those gates, and you can unlock it. So here's obviously combination safe dial. Inside are several it's called the wheel pack, and then on the back is what's known as the drive cam. So the drive cam is directly connected to the spindle, which is connected to the dial, which lets you move these wheels to and fro. And if you look, you'll see the big cutout is the gate. So very similar to the little mini padlocks, but obviously made a lot nicer, made out of metal, not plastic. So, and the cutaway will work its way around. I'll pass this one around too, even though it's a little bit harder to work with. So the basic mechanism by which you open this is you use the dial to position all of the wheels so that their true gate is underneath this little arm, and the arm is called the fence. The piece that the arm is the fence is connected to is called the lever, and then the lever nose, which is the pointy part, is what interfaces with the drive cam. So here's everything getting started. Here's the wheels all aligned so that all their gates are up here. And then when you rotate the drive cam back, it'll have room so that the nose of the lever can fall in. And once that's accomplished and everything else is copacetic, then you can retract the bolt with the drive cam. And I believe the plastic one has the combo written on it if you want to dial it in and see. So safes have a number of ratings. Typically when you buy a safe from like a hardware store or Home Depot, you're usually buying a fire safe. And so safes are distinguished between being fire resistant or elemental resistant or burglary resistant. And so that's what most people don't kind of connect, is that they go, oh, well, I have a safe, shouldn't it be resistant to burglary? Well, not necessarily. Most of the Sentry safes you buy will be fire resistant, not burglary resistant.
And it's also worth noting, since many of us are in the IT field, a fire resistant safe probably is not going to be fire resistant for electronic media such as tapes and that sort of things. All the time you'll see people, oh, well, it's a fire safe, so I can put my backup tapes in it, right? No, fire comes there, it's still going to be hot enough to degauss those. So.
Well, what happens with the fire safe is the idea of the survivability of the papers and stuff inside a fire safe is the material inside the lining of the safe is moist. When the fire heats up on the outside, the inside of the safe turns to steam, which keeps the papers from reaching their kindling point, bursting into flames as the temperature rises. So basically, you open up
they
the
use
fire
a
safe
number of
So
mechanisms.
if you had any kind of like electronic media or anything in there, it's going to get soaked and ruined anyway. So.
Yep.
Yeah. And I'm not going to talk about all the ratings, but there's a number of groups that rate safes. In the U.S., it's typically Underwriters Laboratory, UL. UL 768 is the standard for safe locks in this country. In Europe, it's CEN and BDS and a number of organizations. And there's a photo of a guy. So safes can be attacked in a number of ways. Today, we're just going to talk about manipulation, because that is the most fun. We're not going to talk about fun stuff like thermal lances, even though they are quite fun, or blowing them up and all that other fun stuff. Because that's no fun, right? That's just not fun at all. It's fun to watch, but once you do it once, not that fun. Manipulation, however, is quite fun, and I don't believe we have any slides on manipulation.
No, we don't.
But I will tell you. So, when you dial a combination, this fence and lever here are spring-loaded down. They want to go into the true gates. But they can only do that when all of the gates are aligned. They can only fall all the way down when all the gates are underneath the fence. But how can we exploit that? You'll notice if you pick up all the wheels, and by turning one direction over and over, you'll pick up 1, 2, or 3 wheels. You're going to pick up all the wheels, you'll still hear that noise. So what's that noise? You hear it? What's that click?
That's
What
the
that
fence
is,
going down in that little notch.
what that is actually the fence, or excuse me, the lever nose falling down into the cam notch there. And you could feel that, and right now you could hear it, but possibly not if there's a big wall in between you and the lock. But you can feel that on the dial. You can feel where that point is. And visually, you can identify where these 2 points are, which will be each side of the drive cam gate. So this side is at 57 3/4, and that 3/4 is distinctly important. And this side is at 65 3/4. So we have this little area. You can see here, feeling back and forth. So what happens is when you take all the wheel pack and just turn them to an arbitrary location, and you come back and feel where those points are, you'll probably get that same reading back and forth. But when there's a gate underneath the fence, you will be able to drop just a little bit lower because now there's no material there. And just like our other combo locks, just like our pin tumblers, there's tolerances with all these wheels with the lever. So picture you have 3 wheels like this. Now they're not all going to be perfectly level. One could be a little bit higher. One of the discs could be a little bit oval, so at a certain point it's higher. The fence itself could be a little bit bent. So if the fence is like this, think of which of these things it's going to hit first. So all of these can add up, just like in pin tumbler lockpicking, to this idea of we're going to be able to identify when a gate is under the fence by visual feedback from the dial, as well as tangible feedback with your hands from being able to feel these 2 points. There's a lot to take, I understand. This is something you really need to sit down and do. It's hard to explain and it's hard to understand. But the way it works is that as you put more gates underneath the fence, that lever is able to go lower and lower. And obviously when they're all in the right position, it can fall all the way down. So by picking up all the wheels, we're going to stop at 0. And then you come back, you test that point. You move it to 2.5, you test that point. You're going to go all the way around the dial. And by taking these diagnostics and identifying how far back and forth you can go in this little gate here, you can identify where the wheels are. And that's because as you get the wheels under this, the lever can go lower. And as it goes lower into this V shape, it has less movement back and forth in there. If you think of the dynamics of this, as you go lower, your back and forth movement becomes less and less. But there's also other ways to tell. For example, it's not only when you go lower, but also the way that this is designed, you'll go lower and then come a little bit higher because of the bump. There's a lot of different things you could do to crack this safe. Do you have anything you would like to add, or is that?
I usually just go into like Hobble Hoss and the manipulation proof. But
Well, you know, next.
no, not that.
Okay. Are there any questions on this? I know it's hard to listen to. You really should sit down with the cutaways and play with it to learn more.
And also, who has the little plastic piece? Okay.
No questions? Everybody's a master safecracker now?
My safe has lever on it to open the what you call it, once you get the right.
So what the gentleman said was my safe has a lever on it to open the door. So what that is either A, you have what's called a direct drive safe, where the lever physically pushes into, or the lever on the door physically pushes into the wheels, or it physically pushes into the bolt, and it can't fully turn until the bolt of this type of lock is retracted. Because there's a number of ways to do it. Because sometimes you might want, most of your safes probably have a lot of locking points and very big bolts. And turning this little dial just a little bit is not going to do it. So that's why they have that secondary handle to retract all the bolts. Is it like a Sentry safe?
AMSEC.
AMSEC? It's probably a direct drive safe, which is easier to manipulate. Because you could, just like these combo locks, you could physically push yourself into the gates to get diagnostics. Any other questions?
What are some of the main differences between brands, like different levels of false gates, or do some use like end dials, or?
The question was, what are the differences between different brands of safe locks?
I guess in terms of specifically dial.
Of combination, yes, rotary combination locks. So there's differences between the big boys like Sargent and Greenleaf and Lagarde and Diebold and Mosler. But for the most part, every time you go to like the safe guy in town, you're probably going to be buying this exact lock, just the standard Sargent and Greenleaf lock. And the standard locks from the other companies are all very, very, very similar. They vary,
If not
almost
rebranded.
minusculely, like almost nothing except for the logo on the back will be different. The real difference is when you want to buy a high security safe or a lower security safe, such as a Sentry or an AMSEC or any number of fire safes, which people don't associate with not being burglary resistant. So one example we have is this is a Sargent Greenleaf 8400.
Yes.
They also have an 8500, which I think personally is a little bit cooler. But so the way this works is that you can see the cam looks considerably different. You see there's this big piece right here. And so what that is it locks together to physically block that little part on the cam from being accessible by the lever until you have the correct combination dialed. And so it doesn't stop you from taking diagnostics, but it does, the point is to make it take much longer. So when we rate a safe, either for fire or for burglary, it's in terms of time, not in terms of inevitable, like you can't open this safe. Most safes will be either 10 minutes or 15 minutes or 30 minutes, all the way up to 20 hours. And that's man hours, so it could be one guy working for 20 hours, two guys working for 10 hours, however. This lock, I believe, is rated for 10 hours of manipulation or something like that.
Something like that.
It's a lot. If you think,
If you're going to buy a lock like that, you go say, I want it specified for
Yes.
10 hours,
Yes.
20 hours.
yeah,
But you gotta-
because these are all standardized and either by UL or the other standards organizations to say this is past this many hours of whatever, either if it's lockpicking or manipulation or drilling or fire resistance. Now, you may have doubts as to whether or not the standards companies are accurate with their testing, which is a big thing with locks, or whether or not it's really 15 minutes of resistance, because they may not have been as creative as other people when they standardized and did the testing. But for the most part, I think all of your homes should be safe with this sort of lock. Because if you let somebody really sit there for hours, then, well, first of all, if they're in the door, you already have a problem. If they're at the safe for 10 hours, you have another problem. That sort of thing.
Isn't there, like, the rating, you have like some, I just vaguely remember this from like, back when.
Actually, just as a quick note, sorry, if you're passing that around, make sure not to flip the butterfly switch with it upside down. Because then the
will
whole
fall
part will actually, don't flip that while it's upside down, just like you have it. Make it so that the back is up. And then you can flip the switch. Because if you do it the other way, it'll fall all out.
Yeah. Because it's used to having a back on the
Yeah.
Open.
I'm sorry, what was your question?
Oh, they have this like really strange numbering rating thing, it's like it's a TS-10, which is like
Oh,
two guys with a drill.
Yeah,
Yeah,
And the
that-
TS-47, which is two
And the
guys
TX
with
is
explosives,
explosion.
and this is like.
Yeah,
That's supposed to give you like a number, it's like.
Yeah, the question was, well, what do the ratings mean? Those are all Underwriters' laboratory ratings for safes. And they have a code system that'll tell you really quickly, if you understand the code, what it should be rated for. So TL stands for tools, TX stands for explosives. I don't know all the classifications.
Yeah, they actually
You
do.
could find them
Yeah.
online. I think TR is torch. So if you
And
have-
actually, you'll notice on that safe lock, that's what we call a Group 1R safe lock. So the Group 1 refers to the manipulation resistance. And the R on there, actually, if you notice, those discs are not metal. They're actually a very hard resin.
they're Delaware.
And yeah, they're Datagram. So basically what happens is if you were to use, say, an X-ray on there, you would not be able to see the positions of the discs.
R stands for impervious to radiological attacks. I also dispute whether or not they test properly against that. It's going to be neutron bombardment, neutron bombardment.
Yeah, but neutron bombardment, if you have a portable
work.
neutron
But
bombardment
it's work.
machine, you don't need what's ever behind the safe.
Yeah, those might be slightly cost prohibitive for the majority of attackers.
Yeah.
But it's a consideration nonetheless. This lock,
That actually is no longer production. They replaced that with the 8500 series. That actually used to be the GSA recommended, approved, all that, and they've done away with these now. If you want to be GSA approved for pretty much any high security top secret, they have what's called the Cobble Moss XO9 series, which it's basically, you don't have one over there, do you? Okay.
It's at home.
So basically,
Too expensive to
it
bring around to people.
it's all electronic. So basically what happens is you go up to it, you'll need to spin it first a bit to generate some electricity so it will be able to run. And then there's lots and lots of different protections that safe lock introduces. Like for example, one thing is, are you familiar with how servo motors work? They're very precise, so instead of just being running like that, they go very, very quickly. And so it can detect those motions and say, okay, this is a servo motor, I'm shutting off. If you also notice when you're turning a safe lock, how do you turn a safe lock, right? You turn it like this. There's only a certain amount that your hand can rotate before you have to release, replace, and turn again. So we'll actually know, okay, so if this dial is rotating a certain amount, well, that's impossible for a human hand to do. So, I'm going to shut down because this has to be some sort of robotic thing. And it's actually, when I said this before, it was kind of funny. There was one guy in the audience who said, oh, that's why. And I'm like, sorry, do you want to explain? And so what happens is he had one of these on his workplace, which of course he refused to tell me where it was. But every morning he would go up to it, and of course, like I said, you need to turn it a bit in order to charge, because that's how you induce a charge into it, which is nice since you're not relying on batteries at that point. But what happens is every day he would go up to the safe lock and he would put his arm on there and just go to make it really quick to generate up that charge. And the problem was every so often it would shut down and he would have to wait 10 minutes to get into it. And so the reason is because since he uses this, it would detect that, okay, I'm being turned way too much, I'm going to shut down. It also, when you turn it, it'll go 27, 28, 29, and then you can stop and keep going in the same direction, or if you go a different direction, it won't go 29, 28, 27. It'll start completely randomly and it'll just be,
probably
62, 63, 64.
It's probably the most well thought out lock that exists.
Yeah, there's lots of other protections. It's basically if that safe lock is on whatever your container is, the lock is no longer going to be the weak point, I guarantee it.
You're going to be drilling safe instead.
Yeah.
It'll be considerably easier at the moment than trying to crack the lock.
What's the name of that again?
It's the Cobble Moss XO9. Other fun stuff that they have is for tamper resistance, which is relevant to many of you in the room, is they coat the whole PCB inside the lock with epoxy that has UV particles in it. So when you get your lock, you can take a UV photo of all these particles and see how they fluoresce, and then if there's ever a problem, you can compare to see if your lock might have been replaced. Because it also performs entry auditing and all sorts of other fancy management stuff.
The ICs have tamper resistance on them.
Yeah.
They have the mesh over them, so basically if that's breached, they'll wipe whatever's in
There's
memory.
lots of fun stuff about those locks.
How do you spell Cobble Moss?
KABA space MAS X-09. They also had the 07 and the 08s, but those had various problems, so the X09 is where it is.
Yep, at the moment.
Yep.
Are there any other questions about safe locks or manipulation or combo locks?
Sergeant Greenleaf actually just released what they consider a competitor to the Cobble Moss X09, but honestly, I don't think it's up to the security snuff. Their biggest selling point is, hey, it's made in the USA now. So.
Yeah, I mean, if any of you are concerned, a frequent question we get is, what's the difference really between electronic locks and normal rotary combination locks? The normal electronic locks pretty much suck. So I'm working on some stuff right now to just have fun with like the most basic models, and most of them store like all of your combinations, including like the supervisor combination, like plain text on the chip, and you can have all sorts of fun with like direct access to the microcontroller via the leads that come to the dial. So you just pop off the dial and work with the leads, and you could do fuzzing attacks and all sorts of other fun stuff. You could do man in the middle, see if you can remove the dial and then put it back on, modifying the internals.
The one nice thing that you have with electronic locks as compared to a mechanical lock is a mechanical lock, you're always going to have a little bit of a variance. So if you dial, if the combination is set at 62, you could go 62 and a half, maybe even 63, and it would still be considered the same number that you're getting in the correct combination.
Yeah,
With the digital safe lock, 62 is 62. There is no 62 and a half. There's no 63, etc.
Yeah, you also get built-in auditing for the most part. Some locks do it, some locks don't. They also, lockout features and all sorts of fun stuff.
yeah.
There's a lot of mechanical locks that have electronic add-ons for these features for people who don't want to go spend $10 million replacing all their facilities locks. The other thing I wanted to say was that these are, or at least were, military-grade combo padlocks. I believe this one's still okay, but this one's definitely been phased out. And they're pretty much like little mini safe locks inside. Unfortunately, we can't take them apart non-destructively, but if you go on...
They have at least 3mm plate steel on all sides.
Yeah.
They actually were most commonly used in file cabinets in the military and such.
Yeah, if you go on lockwiki.com, you can see all the internals, and they look very similar to the cutaway combo locks that we were passing around. You see there's a big plate on the back. They have a little shielded dial. They also have a number of counterfeit resistant stuff, such as the dials are all randomly numbered. So if you try and just drill it out, and you'd have to replace it with a dial that has the same thing. And same for the back pieces and the side pieces.
And this one actually is shiny since it's meant to kind of give a little bit of a tamper evident behavior. So if there's any sort of tools that were put on there to
Typically
crank it, or
temperature will change, distort the color of the outside of this to be like a weird reddish color. But yeah. Any questions about safe locks, combo locks? Okay.
all right.
Well, thank you.
Still have lots of locks out here. Have fun.
Yeah, right.
And these are the Sergeant Greenleaf 8077 and 8088 if you're curious.
Yeah.
And if you want to see the how the speed dial works, I've kind of reassembled this one so you can kind of see how it interacts. If you want to come over here.